brief video where we're going to go through the 3 problems from the homework survey that got the most votes. Those are going to be problems 3, 7, and 8. And so we're going to talk about Poisson processes and how this works. So this is the first problem that comes up, number 3. They actually do this problem kind of in a backwards way for what is most useful for us, because we need to put this into class calc. And so the useful thing for us is if we look down here at number E, is that mu sub x equals lambda t, lambda times t. So in this case, this bottom answer is going to be 1.2. Oh, whoops, sorry, not 1.2. I'm not paying enough attention to my math, to the numbers here. Sorry, there we go. Okay. So that's what we want to start out with. So we're just going to take 0.12 times 14 in our calculator. And so we get a mean of 1.68. And then the standard deviation of x is just the square root of that. So we're just going to do the square root of 1.68. So that's rounded to 3 decimal places. That's 1.296. Okay. So that's a useful place for us to start. Because, so just lambda sub x is, sigma sub x is the square root of lambda t. So that's a useful place for us to start because we need mu in order to use our calculator to calculate the rest of these. So to calculate the rest of these, we just go into stat, distribution, and plot and get the Poisson distribution. And then you can see here that it wants you to put in mu, population mean, which for us was 1.68. Okay, and then you can zoom in if you want to see this graph a little better. And so then this works just like the binomial distribution. From here on out, we just use PDF and CDF to do these calculations. So if I want, the first one here is the probability of exactly 4. So we bring up PDF and we just type in 4. And the probability of exactly 4, rounded to 4 decimal places, is 0.0619. Okay. So that's the idea there. Then the rest of these, we're going to use CDF, right? The cumulative density function. There's one interesting thing here. In our problem, it wants us to do x is less than 4. But if we look at our graphing calculator, when we do CDF, we're only given the choices for less than or equal to and greater than or equal to. Well, less than 4, here's the bar for 4, would be anything to the left of 4. So that would be less than or equal to 3. So the probability, when you're and we've talked about this, I think, in both videos now, for Poisson and for binomial, when you're talking about discrete probability distribution, something like the probability that x is less than 4 is actually equal to the probability that x is less than or equal to 3. So that's what we're actually going to put in the calculator here. So we're going to do x is less than or equal to 3. And notice that gives us all 4 bars, 0, 1, 2, and 3, that are less than 4. And it gives us a probability of 0.9098. Okay. So the next one's a little more straightforward, right? It's x is greater than or equal to 4. Greater than or equal to is exactly what we have in the calculator. So we're just going to do 4 is less than or equal to x. And notice that gives us 4, the one at 4 and all the way to the right are now highlighted. So that's the ones it's giving us the probability of. So that's 0.0902. And then last but not least, we're doing between 5 and 7. So that one's really easy to put in because we're going to put in exactly what it says into the calculator. So 5 is less than or equal to x, which is less than or equal to 7. That gives us these 3 bars, which is 0.0280 is our probability. Okay, so that's a nice problem that's just asking you to use what's in the video lecture and the notes without any application to it. Right? It's just plugging numbers into Poisson. So then the other 2 problems are applications. So the first one here says, for the past 108 years, a certain state suffered 30 direct hits from major category 3 to 5 hurricanes. Assume that this was typical and that the number of hits per year follows a Poisson distribution. Complete parts A through D. So the important thing for us to notice here is that these two values are actually telling us the rate at which hurricanes hit, the expected rate, which is lambda. So in this case, our lambda is 30 hurricanes per every 108 years. And then to find our mean and plug it into the function, what we need to know is over what period of time are we doing the problem? And over the period of time we're doing the problem is a single year. So t would equal 1. So mu sub x, which is what we're going to put into our calculator, is 30 over 108 times 1, which is just 30 over 108. Okay, so that's what we're going to come in here. So in our Poisson distribution, I'm just going to change 1.68 to 30 divided by 108. And then I can zoom again if I want, and it looks like this. And let's clear out our density functions. And so then we can start doing the probabilities. So the first one says, what is the probability that the state will not be hit by any major hurricanes in a single year? So that's just the probability that x equals 0. Okay. So we're just going to put 0 into our PDF function, and that's 0.7575 when we round to 4 decimal places. 0.7575. So then what's the probability that it will be hit by at least one major hurricane? So at least one is the probability that x is greater than or equal to 1. Okay. So we can go in here and we can use our cumulative function to say 1 is less than or equal to x. So notice at least 1 would be 1 or 2 or 3 or 4 or and so on. So it only got rid of this bar for 0. And the probability of at least 1 is 0.2425. And so that would not be unusual because that's not less than or equal to 0.05. Sorry, 0.05. So 0.2425 is not less than 0.05. So therefore, that would not be unusual. So it wouldn't be unusual for this state to get hit by a Category 3 to 5 hurricane in a given year. Okay. So then... Oh, sorry, you can't see what I wrote. So yeah, so the answer is no because 0.2425 is not less than 0.05. So then what's the probability that the state will be hit by at least 3 major hurricanes? So that would be the probability that x is greater than or equal to 3. So in our calculator, we're just going to change this 1 to a 3. And the probability of that's pretty low. It's 0.0029. Okay. And so does that indicate that the hurricane season several years ago in the state was unusual? Yes, right? That is less than 0.05. So being hit by 3 major hurricanes in a given year would be unusual. And then what is the so then what is the probability that the state will be hit by at least 2 major hurricanes? So that's the same idea, right? So the probability that x is greater than or equal to 2. So we can put that in. We just change this to a 2. And so that's 0.0321. And so does that indicate that the hurricane season for this year was unusual? And the answer is yes. Because once again, 0.0321 is less than 0.05. Okay. So that's the idea for problem 8. And then problem 7. And then for problem 8, we have a similar idea. Okay. So one study showed that a certain year airline fatalities occurred at a rate of 0.017 per 100 million miles. Find the probability that during the next 100 million miles of flights there will be, and then as follows. So our lambda here is 0.017 over 100 million miles. And then our t in this case is not actually a time, but it's actually a distance. So in this case, they want to know over the next 100 million miles. So that's our t, 100 million. So then our mu would be 0.017 over 100 million times 100 million. And so the 100 millions cancel, and our mu is just 0.017. Okay, so that's what will go inside our Poisson distribution function. Okay. And so then we can start doing problems with that, right? So let me zoom in on it like that. So what's the probability of exactly 0 deaths? So PDF of 0, we already have in from the last problem, is 0.9831. So there's a very high probability that there will be no deaths. So there will be, what we calculate here is exactly 0 deaths. In approximately, that's where the approximate comes in. And then you just multiply 0.9831 by 100 and round, and so that's 98. 0.9831 times 100 is 98 out of every 100 randomly selected 100 million miles of flight will have 0 fatalities. Okay, no one will die. Okay, then we can do, and once again, I didn't bring up this so you guys can't see what I wrote. So there will be exactly 0 deaths in approximately 98 of every 100 randomly selected 100 million miles of flight. So then for the next one, they want us to do the probability of greater than or equal to 1. So you can just put that in, right? 1 is less than or equal to. And so that's 0.0169 is that probability according to our calculator. So in this case, there will be at least 1 death in approximately every 200 randomly selected. So that's 0.0169 times 100. Same idea as above. Gives us this 2 when we round. And then, so that's part B. And then part C, it wants to know what's the probability that X is greater than 1. Okay. Well, greater than 1, just like we talked about in the previous earlier, the probability that X is greater than 1 is the same thing as the probability that X is greater than or equal to 2. So we can change this 1 to a 2 in our calculator. And so now we get a probability rounded to 5 decimal places of 0.00014. Right, 0.0014. So that means there will be more than 1 death in approximately 0 of 100 randomly selected 100 million miles of flight. Because if you multiply 0.00014 times 100, you get 0.014, which rounds to 0. Okay, so those are all the problems that got flagged in the homework surveys. I hope this video has been helpful. If you have questions about these or anything else, feel free to shoot me a message. Don't forget you have a test next Thursday. And the practice problems are on Blackboard page, and I will have physical copies of that for you in class on Tuesday, along with physical copies of the Chapter 7 notes, if you would like either of those.